Student, now we are entering one of the most important units in explainable AI. So this unit is not just theoretical, it directly connects how the AI systems are used in real world decision making. So you might have heard that AI is powerful, but power without understanding is dangerous. So, in this unit, we are going to learn how to make AI systems not only powerful but also understandable. Let me first tell you what we are going to cover. These are the three main topics. The first is optimizing sparse logical models and especially decision trees. The second is something slightly advanced, disentanglement in neural networks. Don't worry, I will break it down in a very simple way. The third is dimensionality reduction, which help us visualize complex data. So now, why are this topic grouped together? Because all three aim at one goal. Okay, so making the machine learning models easier to interpret. So when I say interrupt, I mean a human should be able to understand how the model is making the decision. In the real life, think about a doctor using AI. If the AI says this patient has a disease, the doctor will not accept it blindly. As already many times I told this example for every slide, for every content. Okay, so the doctor will ask why. So what the symptom led to this conclusion? That is exactly what we are solving here. So similarly, in the banking, if a loan rejected, the customer has the right to know the reason. So the transparency becomes very important. So throughout this unit, keep one thing in mind. We are not just we are not just building the models. Okay, future engineers. So we are building the trustworthy models. And I want you to think like engineers, not just how to build, but how to explain what you built. Okay. So now let's talk about the main problem. The most of the modern machine learning machine learning models, especially deep learning models, behave like a black boxes. What does that mean? It means you give some input, you get some output, but you don't know what is happening inside. So let me give you simple analogy. You mean, imagine you go to a doctor, the doctor gives you medicine without explaining anything. Will you feel comfortable? No. You will ask, what is this medicine? Why should I take it? What are the side effects? Okay. Have you asked the question to the doctor? Yes. Similarly, in the AI, if a model give a decision without explanation, people will not trust it. So this become even more critical in sensitive domains like a healthcare, finance and law. So in these areas, wrong decisions can have serious consequences. So another issue is debugging. So suppose your model is making wrong prediction. If you don't understand how it works, how will you fix it? Also, there are the government regulations now. Many countries require AI system to be explainable. So this is called right to explanation. So the key challenge is how do we balance accuracy and interpretability. So earlier the people thought if you want high accuracy you must sacrifice interpretability. But now with the explainable AI technique, we are trying to achieve both. So always remember this balance: accuracy plus interpretability plus simplicity. That is the foundations of today's lecture. Okay, now let us move our first concept, sparse logical models. The word sparse might sound technical, but it simply means less or minimal. So in this context, it means using fewer rules. So fewer rules, fewer features, fewer conditions, which mean less or minimal. So a very common example is the decision trees. You might have already studied in decision trees, but now we are looking at them from an explainability perspective. So a decision tree works like a flow chart. At each step, it asks a simple question based on the answer. So it moves to the next step. For example, in a loan approval system, the tree might ask, is the salary greater than 50,000? If yes, go one way. If no, go another way. Now imagine a very large decision tree with 100 of nodes. It becomes difficult to understand. So we try to make it sparse, which means less or minimal. So that means the fewer nodes, simpler structure. So why this important? Because the humans can only understand limited complexity. If a model is too complex, it loses its interpretability. So sparse models are also faster. So they require the less computation and are easier to deploy. So another advantage of is this, they reducing the overfitting. So when a model is too complex, it memorizes the data instead of learning patterns. So sparse logical model help us in three ways. They improve the interpretability, efficiency and generalization. So, and this is why they are widely used in the real world application. Have you got it? So any doubt about the sparse logical models? Hope you understood very clearly. Okay, shall we move the next topic? Now the question is, how do we make the decision tree sparse? So this is where the optimization comes in. The first technique is pruning. So pruning means cutting off unnecessary branches in the tree general terms. So the pruning means cutting off unnecessary branches. Suppose a branch does not contribute much to accuracy, we remove it. So there are the two types of pruning, pre-pruning and post-pruning. So pre-pruning stops the tree from the growing too much. Post-pruning remove the branches after the tree is fully grown. So next is feature selection. So not all the features are important. For example, in a predicting student performance, maybe hair color is irrelevant. So we remove the such features. Another technique is cost complexity pruning. Here we balance between accuracy and complexity. So we don't want a very complex tree, even if it gives a slightly better accuracy. So we can also use constraint like limiting the depth of tree or limiting the number of nodes. Okay, have you understood? What are the four techniques? Have you understood clearly? So first one is pruning, second one is feature selection, third one is caste complexity pruning, fourth one is constraint based tree growth. Okay. So the final result is the tree that is smaller, faster and easier to understand. Always remember the goal is not just accuracy but the clarity. Because a slightly less accurate but the interpretable model is often more useful in the real world applications. Have you got the word? So this is a medical diagnosis case study. I'll see later. Now we move to the slightly advanced topic, disentanglement in neural network. So neural networks are powerful, right? But very complex. Inside them, features are mixed together in a way that is hard to interrupt. So, interpret. Disentanglement means separating these mixed features into independent components. So, separating these mixed features into independent components. Let me give you simple example. Suppose you are analyzing the images of faces. Okay. Uh, these are the different factors. What are the factors for analyzing the image of faces? Like age, gender, emotion. So in a normal neural network, these factors are mixed. So one neuron might represent the combination of age and emotion. But in a disentangled network, each neuron represents one specific factor. So one neuron for age, one for emotion, one for gender. So this makes the model much easier to interpret. It also helps in controlling the model. For example, you can modify only one feature without affecting others. So supervised disentanglement means we use labeled data to guide this process. So we explicitly tell the model what each feature should represent. So this improves the transparency and reduces the bias. So disentanglement is a powerful technique to make a neural networks more explainable. Have you got it? So why disentanglement is important? It improves the interpretability and it also better control the over prediction, reduce the bias, uh, enables the debugging of NN decisions. So support fairness and transparency. Okay. So this is the case study of disentangled future. I will explain all this case study at the end of before thanking session. Now let's move to the final concept, dimensionality reduction. In the real world data set, we often have 100 or thousands of features. So this is called high dimensional data. Such a data is very difficult to visualize and understand. For example, imagine trying to visualize the data with 100 dimensions. It is impossible for the humans. So, we reduce the number of dimensions while preserving important information. This is called dimensionality reduction. The common techniques include PCA, TSNE, and the UMAP. So these techniques convert the high dimensional data, which means 2D to 3D. Now we can visualize if using the graphs. So this helps us see the patterns, clusters and outliers. For example, in a customer data, we can identify the group like premium customer or at a risk customer. So the dimensionality reduction, it also helps in the noise reduction and a faster computation. So it plays a very important role in the making a data understandable. And remember, visualization is a powerful for explainability. Okay, let me conclude the session. So, students, forget the theory movement. This is a dimensionality reduction. So here, data visualization using dimensionality reduction before reduction and after reduction. So this is a case study. Okay. So students, forget the theory for a moment. Let me talk to you into a real world situation. Imagine you are working as an AA engineer in hospital. A patient comes in, the AA system says high risk of heart disease. Now the doctor look at you and ask why. Can you answer? If your answer is, you might be answered. If your answer is, the model is predicted, that is not acceptable. Always mission is a mission. So this is where the explainable AA becomes critical. Today I will show you how the concept we studied, decision trees, disentanglement and dimensionality reductions actually work in your real life. So first case study, scenario 1, healthcare diagnosis. So let's, in healthcare diagnosis, we saw the sparse models actually work in real time. Let's start with the healthcare. A hospital built an AI system to predict the diseases using the patient data, which mean the features. What are the features? Features mean inputs. What are the inputs are there? Age, blood pressure, sugar level, cholesterol. Now imagine the two situations. Case 1, complex black box model. Case 2, sparse decision tree model. First one, complex black box model. So this model, this is detected only. Doctors ask which symptom caused it. Is it blood pressure or sugar or BMI is high? The model, no explanation. Just I'm detected the disease only. So now what happened? The doctor doesn't trust it. No, patient is confused. So the legal issues may rise. This is very dangerous. Okay. Actually, we give a input, we get an output. What happened inside, we don't know. So in a healthcare is a sensitive. It is important department, right? So the doctor doesn't trust it, the people doesn't trust it, the patient is confused. Finally, the legal issue may be arise. So in a case 2, our sparse decision tree model. Now we use a simple optimized decision tree. The model say if a BP greater than 140 and sugar greater 180 and the high risk, else low risk. Now the doctor understand immediately, he can explain to the patient. So your BP and your sugar levels are the reason for the high risk. So student, this is the power of sparse logical models. So we are not just predicting, we are explaining in the human understandable way. So in the real optimization use, in the real hospitals, they remove the unnecessary conditions. They limit the T depth. They use only one important features. Why? Because doctors don't have to time analyze 100 rules. They need fast, clear, trustworthy decisions. Right. I'll tell you the another scenario example. The loan approval system. The loan approval system contains that beyond the topic decision tree and interpretability. Now let's move to the banking. Imagine a customer apply for a loan. The AI system reject it. The customer asks, why was my loan rejected? The black box answer, your profile is not suitable. This creator is the right answer? No. So this creates customer frustration. Why? Why? Okay, is the app say that my profile is not suitable? So, but it also creates the lack of transparency. Okay, but the customer does not suggest to anyone, don't use this app, don't use this bank, like that. So the possible legal complaint. So these are the factors are created. Simply your profile is not suitable. So explainable model using the sparse rule, if the income less than 25k, you are rejected. If the credit score less than 650, you are the rejected. So now the bank clearly say your credit score is low, your salary is low, you are not appropriate to pay the loan, you are not eligible. Okay. So students, this is not just a technical, it is an ethical AI. So in many countries, this is a legally required. So this is called right to explanation. Right? So banks are today prefer interpretable models, even sacrifice a little accuracy because the trust is more important. So remember this, a slightly less accurate but explainable model is often better in real life. The third scenario, face recognition system. Here the concept disentanglement is used. Now let us go to the more advanced system, face recognition. So in every office or in every college, in every working sector, we have used face recognition. You upload a photo. AI detect age, gender, emotion. But how? The normal neural network, okay, inside the model, features are mixed. So one neuron represents many things. So if the output is wrong, we don't know why. But the disentangled neural network, we design the model such that one neuron for age, one neuron for emotion, one neuron for gender. Now if prediction is wrong, we can trace which feature caused the error. Right. So this helps to reduce the bias, improving the fairness and debugging the models. So let me relate this into you. Suppose your marks, okay, relate into you. Your marks, okay. Suppose your marks are low. Instead of saying student failed, we break it into attendance problem, assignment issue, exam performance. Now the solution become clear. This is exactly what disentanglement is. Okay, have you got it? Okay, I would like to tell the fourth scenario. Now imagine you are working in an e-commerce company like an Amazon, uh, Flipkart, like that. You have a customer data. What is the main features? Age, income, browsing history, click patterns, purchase behavior. Not here name, not here address, not like that. Okay, age, income, browsing history, click patterns, purchase behavior. So the hundreds of features. So the problem, can you visualize the data? No, it's too complex. Okay. So some more, say for example, some 10 customer data will be displayed visualized. 100 data will be visualized, but thousands not possible. Lakhs not possible. So the solution, dimensionality reduction. We use a technique PCA. and T of S and E. Now we convert this into 2D. So suddenly we see customer clusters. So we identify premium customers, discount seekers, at-risk users. So now company can some business impacts. What is that? What are their target ads? Improve the sales and the prediction. Okay, so student visualization is not just for graphs. Okay, it's not just for graphs. It is for understanding the hidden patterns, and that is the key part of explainable AI. Okay, so final I would like to tell the real world wrap up. Let me connect everything now. In a healthcare, the sparse models help the doctors trust AI. In a banking, the explainable rules ensure the fairness. In a neural networks, disentanglement improve the transparency. In a business, dimensionality reduction reveals the insights. So, students, in your career, don't just aim to build an intelligent system if you are an AI engineer. So, build a system that human can understand, because in this future, the best AI engineer is not the one who build the most complex model, but the one who build the most trustworthy model. Okay, have you got it? Have you got my word? So in every slide I told like that. Okay, let me move the next slide. The summary and takeaway. Okay, finally the summaries. The sparse logical models improve the trust. The disentanglement explain the neural networks. So the dimensionality reduction enable the visualization. So interpretability, accuracy, loss. Okay, human friendly ML is a good feature. Okay, in the summary and takeaway we already told that. Okay, so there we already told that what is the main most three concept. What is that? uh, the main most three concepts are, the first one already I told, that sparse logical models. Okay, the most of the modern machine learning models, especially deep learning models, behave like a black boxes. What does that mean? It means you give some input, you get some output, but you don't know what happening inside. So let me give you simple analogy. So imagine, I already told that you go to the doctor without explaining everything, the doctor won't trust like that. Okay. So this become the even more critical and sensitive domain like healthcare, finance and law. Okay, so now let us do the first concept of sparse logical model. The second concept is optimization of decision trees. And then third concept is disentanglement. Okay, the three are the main concept. Finally, the most important concept of dimensionality reductions. So human friendly ML is the future. So this is the summaries takeaway. So the final conclude of the session is, we studied the three important techniques for the explainable AI. The sparse model help simplify the decision making. The disentanglement help the interpret neural networks. The dimensionality reduction help the visualize complex data. So all these techniques aim at one goal, making AI understandable to humans. And this is very important for trust, fairness and real world usage. So as a future engineers, your responsibility is not to just to build a model, to build the model. Actually, frequently I told that, okay, can trust. That is the true essence of explainable AI. Okay, hope you understood. Any doubt regarding this?